This week, a cheap Serious Agent API learned to see, while local work targets mixture of experts and long prompts. The headline is, DeepSeek V4 Flash Vision Experimental released today, and it is an API release rather than a local download. DeepSeek says it preserves V4 Flash text agent, reasoning, and world knowledge while adding image understanding. It accepts screenshots, charts, and terminal captures through the standard API. Agents can use URLs, base64 input, or reusable files API uploads to inspect work rather than only read it. DeepSeek's own numbers make this more than a feature checkbox, because Vision Experimental stays in Flash's text agent range. The visual tests are the sharper result. At ApexBench, it posts 36.5 versus 26.2 for text-only Flash, and 39.4 for Opus 4.8. On Agent's last exam, it reaches 27.3 above Flash at 25.2 and Opus at 25.7. Chartography is 64.3 against Opus at 65, and Zero Bench is 35 against 34. These are vendor numbers, so treat the comparison as a claim to test rather than a settled verdict. DeepSeek says text-only Flash ignores the multimodal parts of some comparisons, which explains part of the jump. Image inputs are capped at 384 build tokens each and use Flash pricing, which makes a vision-capable agent plausible for inspecting dashboards and generated interfaces. It is still cloud inference rather than a substitute for a local vision model. The local relevance is the workflow, because cheap visual agents can join the toolchain, while open-weight systems work toward the same capability. The most immediately runnable release is Ornith 1.5. The family includes a dense 9 billion parameter reasoning and agent model with tool support and a native context of 262,000 tokens. Its model card puts SWE bench verified at 70.6 against 53.2 for Qwen 3.59 billion. A community llama.cpp GGUF release then added a distilled multi-token prediction head. The bundled 4-bit file is 5.8 gigabytes, so it does not need a separate drafter. The official base configuration advertises an MTP layer, but does not ship its weights, making this a third-party artifact rather than an official Ornith quant. Its Blackwell test shows the opportunity and the limit. At 8-bit, decode rises from 149.6 to 264.5 tokens per second at the best draft depth, 1.77 times faster. The 4-bit build gains only 13% and becomes slower on Creative Pros when acceptance falls. MTP is not a free switch. Its value depends on the quant and on how predictable the next tokens really are. That is, the constraint S-squared MOE targets for mixture of experts models. Normal speculation can wake a different set of experts for each bad draft, and on an offloaded model, that traffic can cost more than the draft saved. S-squared MOE estimates activation cost, then favors experts already active in the batch, and shares the target KV cache with the draft. It is a research llama.cpp fork rather than an upstream feature, but it addresses hardware local users actually hit. In one Jetson Orin 32 GB human eval result, OLMOE rises from 2.3 to 12.08 tokens per second, while Eagle 3 reaches 2.96. That needs broader reproduction before it becomes a general recommendation. Long contexts need a different fix, because decoding speed cannot repair the weight before the first token. FlashPrefill V2 is a block-sparse prefill project built around paged KV cache and continuous batching in SGLang. It adds a correction path instead of simply discarding sparse attention mass, and reports up to 4.8 times lower time to first token in FP8 at 128,000 tokens. Those are H2O and 4 GPU results, rather than a desktop benchmark or an upstream SGLang release. The common thread is that local AI is becoming a mixed systems problem. DeepSeek is making visual API agents cheaper, while Ornith gives a compact local agent an MTP experiment, and new work targets expert traffic and prompt delay. The next question is, which ideas reach the runtimes we actually run?